I'm Lee Park. I'm in the chemistry department at Williams College, and I'm going to talk a little bit about doing research with undergraduate students, as distinct from the work that we do with students in our laboratory courses. So when we take students into our research labs, we are really training them to become scientists. And what we do in our research labs, although it's not always counted as such, really is a form of teaching and training. It is, for our students, increasingly required by graduate programs that they have research experience. So it's really an important part of their training, and it's one that we take very seriously. When we take research students into our labs, they're going to start working in our labs on the projects that we already have ongoing in our labs. And so one of the challenges is designing projects, pieces of those projects that are appropriate for undergraduates. I think that one of the mistakes that I made early on was that I gave students projects that were perhaps a little bit more designed with sort of graduate students in mind. That is, I gave students projects that were sufficiently distinct, and my thinking was that they would feel more independent and feel more ownership of having their own projects as distinct from each other. And over the years, what I have started doing is grouping students onto projects that, if you were a graduate student, you might be a little offended, in fact, to be working so closely with another graduate student. But what I find with undergraduates is that they're so inexperienced that, in fact, working closely with some of their peers is far more reinforcing and allows them to sort of talk through problems with one another and sort of sort through kind of mundane details with one another. And so I found that works much better for me. Finding ways for students to communicate with each other about what they're doing in their project and how their project relates to the projects of other students in the lab is also an important piece. It's easy for students to get very caught up in the details of their experiment and lose sight of kind of the bigger picture of what you're trying to accomplish as a group. So I find that very important as well. Over the years, another thing that I've learned is that I have far more money than time, and that took me a long time to learn. In graduate school, of course, my research advisor had far more funding than I have as a faculty member at a small institution. And so at first I thought I had to really conserve my money. But what I've realized is I actually have far fewer hours than I have far less time than money overall. And that so I've sort of switched how I think about spending the resources that I've got in terms of the time that I've got with my students, the kinds of equipment or reagents that I can buy to sort of speed things along a little bit. My perspective on that has really changed over the years. We're very fortunate here in that we have a lot of resources available to us. The college is very generous with funding for student stipends. We are very well positioned to apply for grant money from a variety of public and private agencies. And we get really good students. And so that's all, we're very, very well positioned in terms of all of those parameters. So that's wonderful. Nevertheless, you sort of have to pay attention to what's going on in your lab. Students are very enthusiastic, but they don't tend to have a very realistic picture of what it means to do research, so they can get easily frustrated, which is natural. And they don't always know how slow and how persistent you have to be to really make progress in a research project, and so sometimes you spend a lot of time encouraging them and reassuring them that the fact that a given experiment didn't work the first 2 or even 3 times is not at all unusual. But it's a lot of fun. I mean, part of the fun about doing science is that it is so highly collaborative, that you work so closely with other people. And I think we all remember that we were trained by somebody, and it is a part of science training. And so it's a lot of fun to be on the other side of that and to work very closely with students and to provide them that training. I think it's important to talk to colleagues of yours who are doing similar work, to really think hard about how you design experiments for students and what will work for them, because that can be a bit of a challenge. But in the end, it's a lot of fun, and it's something we spend a lot of our energy on, and it's something that I think students treasure. They really, it's one of the experiences that we give them that the students most appreciate, and I think really does the most in terms of training them to be scientists.